We are next going to work from the handout on lines and linear functions that's posted as a PDF in Canvas. We begin this handout with a review of lines. I'm just going to skim over the important facts that you need to know about lines and graphing lines. And we're not going to do any problems with this. So if you need practice, you may need to consult another resource like Khan Academy or another textbook to practice some problems on lines. So this is all information you should know. Any equation of the form ax plus by equals c, where a and b are not both 0, has a graph that's a straight line. Any non-vertical line has a slope. Slope is an incredibly important concept. It's traditionally denoted with the letter m, where m, the slope, is equal to, now it's described in different ways in different books and in different courses. So you may have seen rise over run. Sometimes it's described as this delta y over delta x. This triangle is a Greek letter called delta, and it stands for change. So it really means change in y over change in x. If we state this in terms of function inputs and outputs, it's the change in output divided by the change in the corresponding input. So those all describe the same thing, slope of a line. And if you know the coordinates of 2 points of a line, say x1, y1, and x2, y2, then we can write the slope m as y2 minus y1 over x2 minus x1. And I bet most of you have seen this formula somewhere along the way. You can actually plug in coordinates of points into this formula to get the slope. It's saying the same thing as what I circled up above, because y2 minus y1 is delta y is the change in the output. x2 minus x1 is delta x, it's the change in the corresponding input. So just make sure when you apply this formula that you got to be consistent. So if you start with the y coordinate of a certain point up above in the subtraction, you need to start with the x coordinate of that same point down below when you subtract. If b is not 0, then we can write the lines equation in the useful form, this form y equals mx plus little b here, where m is the slope and little b is the y-intercept of the line. This is the famous slope-intercept form of the equation of a line. Sometimes we know the slope m and the coordinates of one point, x0, y0, that lies on the line. In this situation, we can use this formula, y minus y0 equals m times x minus x0, to obtain an equation. This formula is not mentioned in our textbook, and we're not going to use it in that form, but it is useful in calculus, and you may see it in calculus courses, and it can be converted to y equals mx plus b. You can actually go get it into this form. It's a useful form for plugging in a certain, when you know the slope and just one point of a line. The equation of any horizontal line can be written in the form y equals a constant. The equation of any vertical line can be written in the form x equals a constant. Parallel lines have equal slopes. Perpendicular lines have slopes that are negative reciprocals of each other. Perpendicular lines meet at right angles, right, like the corner of a sheet of paper. And so what does this idea of negative reciprocal mean? Let's just look at an example. If I had maybe 4 and negative 1/4, those two numbers are negative reciprocals of each other. Or another example might be 2/3 and negative 3/2 are negative reciprocals of each other. if a line is rising as we move from left to right, it has positive slope. So rising from left to right, I think of as looking sort of like so. So there's an example of a positive slope line. If a line is falling as we move from left to right, it has negative slope. So a line with negative slope is going to be kind of pointing in a direction like so. Now we're going to focus in this course on linear functions. Lines are going to turn up as graphs of a certain kind of function we call a linear function. And the form of a linear function is f of x equals mx plus b. And yes, this is exactly the same as writing y equals mx plus b. There's no difference there. F of x just stands for the output y. But we are going to use function notation a lot, so we're going to prefer this way of writing the slope-intercept form of the equation of a line. Using function notation, 2 points on the graph can be described as x1 comma f of x1 and x2 comma f of x2. So x1 is an x-coordinate, f of x1 is just a y-coordinate. This corresponds exactly to saying x1, y1, but instead of y1, if we use function notation, we write f of x1. So try to get used to that, because I know you see that x in there and you're saying, is that an x? Well, it's not an x anymore, because f of x1 stands for the corresponding y-coordinate. And the same with f of x2. So we have x2 comma, that's really just a y2. Now when we use function notation in this way to represent the y-coordinates, the slope formula takes this form. So think about this for a moment. Instead of writing y2 minus y1, like we did up above there, which is maybe the form you're familiar with, since we're using f of x1 and f of x2 for the y-coordinates, we can write that exact same formula as f of x2 minus f of x1 over x2 minus x1. So that's our brief little introduction here. I think we'll stop this before we start exercises. We'll do exercises in the next video.